Okay. We're going to quickly look at just solving, and they've written this as the quadratics of a specific form. So we're going to say quadratics of the form, and you guys usually write things, they are writing them x squared is equal to k, I believe they're writing them as. Let's jump back one page. Yeah. So what you have here is they want you to solve for x in these following questions here. So we'll go through the first one here, and then we'll try to get you to go through the other ones as we go through. The idea is just to simply isolate for x. So since we have that coefficient of 3 as part of it, what we're going to do is we're going to divide both sides by 3. When we do that, we kind of cancel it out, or we create a 1 on the one side. So we have x squared is equal to 8. And then this is where to isolate for x, we have to find the square roots. So we're looking for the square root of both sides of this equation. We look for the square root because that cancels out the power of 2 on the left side. So we get x is equal to 8. And here we're going to get two values for 8. Okay, so we're going to get both a positive and a negative value. And I just want to quickly, here we go. I'm going to show on Desmos here. Let's start a new one. Okay, when you have a graph like that, squared, and they've written equals 24. Okay, when we zoom way out, oh my gosh, it's huge, this one. What we're looking at is these two are the values. These are your x-intercepts. So those are really weird numbers. But if this actually works as a calculator too. If we actually just write in the square root, where is the square root function on this? I think it's down here. There it is. Square root of 8. You'll notice the square root of 8 is actually equal to these. So the positive and negative value. So you can rewrite this equation. They haven't really written it with a y value here. But you could say that our, as we go to solve it, we could say that y is equal to 3x squared. Where's my 2? Let's say minus 24. Oh, crap. Okay, so we can recreate it using this graphing calculator, and you'll see that the values end up being the exact same as the root 8, just like we did in this question. Okay, so with that being said, let's try the next one here. You want to try this together?
Sure.
Okay, so we have the left side of the equation. What would we do to isolate for x here?
You subtract 1 on this side.
Okay, so we subtract 1 on each side. What will we end up with?
You will have 2x squared is equal to 14.
Okay, great. So we subtracted 1 from both sides. And then what?
And then divide by 2.
Great.
And x is equal to positive and negative 7.
Just x? X is equal to positive.
X squared.
X squared is equal to positive and negative?
No, it's equal to 7.
Okay.
And then x is equal to positive negative square root of 7.
Very good, because we square root both sides, right? Mm-hmm. Good. Okay, the next two are fairly repetitive. It's the same concept as this. There's a few more steps involved. Let's go through them. They're just going to test your ability of balancing equations. We won't go through the bottom part, but let's quickly try the next one too. What would I do on the third equation here?
Negative 3x squared plus 2 is equal to 8. Then subtract 2 on both sides. Negative 3x squared is equal to 6.
Okay.
Then divide by negative 3x squared is equal to negative 3x is equal to square root of negative 3.
X squared is equal to negative 3. And then
x is equal to the square root of negative 3.
Okay. A value for the square root of negative 3. Let's test this. Let's quickly go into our scientific calculator. Square root negative 3, and it gives us an undefined value. Why is that?
Because there is none.
Yeah, when we're looking for square roots, it's two numbers that have to be identical.
There's nothing times the same thing. No two positive numbers can equal a negative, and no two negative numbers can equal a positive.
Yeah.
I mean a negative.
Exactly. Very good. So let's take a look at this. Negative 2x squared is equal to 8, was it? Do we have a value of it? It doesn't look like it shows up in this one. No, we have an undefined value for it. So we're looking at something where we're looking at it has like no roots to it. So we've dealt with quadratics before that don't have roots. So we're going to think of that when we're looking at this one. And finally, let's talk about the last one. What would you do for this last question here?
It's I don't remember how to do this.
Okay. This one is a half. Okay. And you can divide by a half also. It's actually identical to multiplying by 2. So we can actually just multiply both sides by 2 because a half times 2 just gives us a value of 1. Okay. So when we have that value of 1, we're left with bracket 2x plus 3 squared is equal to, and 5 times 2 is 10. Okay. Now what we're going to have to do is we're going to have to square root both sides of these equations. And here we'll end up with 2x plus 3 is equal to root 10. And I could write plus or minus in front, but we're just going to leave it for now. We'll be aware that we're going to end up with 2 answers in the end of this. I would then move 3 to the other side. So we'll subtract both sides by 3. We're kind of short for space here, so we'll keep going. We get 2x is equal to root 10 minus 3. And then finally, I have to divide all of that by 2, so we're going to jump below here. We're going to get x is equal to root 10 minus 3 divided by 2. And technically, you would say there's 2 answers here. We could say x is equal to negative root 10 minus 3 over 2, and x is equal to positive of root 10 minus 3 over 2. And that's where you get that dual answer, where you get your multiple roots when you're solving something. Okay, so